All right, a toy car, 6 kilograms, experiences this crazy force. And we want to know, we're told that at t equals 0, the velocity is 4 meters per second. And we want to know when the car comes to rest. So let's get the acceleration as a function of time. So it looks like the acceleration is going to be negative 3 t over the mass, which is 6, which is negative t over 2. Now, we want to know when the car is going to come to rest. So let's get a function for v. So we're going to say v equals a dt integrated. And so that's going to be negative t over 2 dt integrated. And so v of t is going to equal negative t squared over 4 plus c. And we're told that t equals 0. We're at 4 meters per second. So that means 0 equals negative 0 plus, at time equals 0, we're going at 4 meters per second. So 4 equals negative 0 plus c, so c is 4. So our function is going to end up being, for number 11, v equals negative t squared over 4 plus 4. So when we get a speed of 0, let's find out. 0 equals negative t squared over 4 plus 4. So t squared equals 16, so that's going to happen at 4 seconds. What would be the best graph of the position versus time? So let's just integrate one more time. So we're going to end up getting negative t cubed over 12 plus 4t plus 8 when we get our integration constant. And so the position versus time, we need some kind of a cubic function here. And it looks like at first we got a positive displacement. At 0, we're at 8. And then we'll go forward for a little bit longer, but this cubed term is going to win in the end. So we're going to end up getting something at curves like that. So I'm looking basically at choice E. Oh, that's a mean question. Glad we're doing antiderivatives. All right. How far does this object travel during the first 10 seconds? Man, I'm just throwing these integrals at you. 2t plus 3t squared dt integrated from 0 to 10. My goodness. That's going to be t squared plus t cubed from 0 to 10. I'm getting 1100 meters. And the instantaneous force, let's get the acceleration. That's going to be 2 plus 6t. And at 2 seconds, the acceleration is going to be 14 meters per second squared. So that means the force is going to be 10 times 14, which is going to be 140 newtons. Whoa! And then the work done by this force between 0 and 1 seconds, oh my gosh. You know what? Let's do a little bit of a different take on this. Instead of doing f dx, you could do that, by the way. This is a terrible integral. If you want to do this, it's this crazy implicit differentiation, integration weirdness. It's like you would do f times dx dt times dt, because x is a function of t, and it's all this weird. Okay, I'll show you how to do it if any of you are interested. Mr. Lewis can show you if you're interested in integration. But for us folks that want the easy way out, work is the change in kinetic energy. So let's just do this. V at 0 seconds is 0. V at 1 second is 2 times 1 plus 3 times 1 squared. So that's going to be 2 plus 3 is 5. So my change in kinetic energy is going to be 1/2 times my mass, which is 10, times 25. So I'm getting 125 joules worth of work. Pretty cool. All right. We're walking along a circular path in number 16. We got 50-meter radius. So one person, let's call him or her halfway around the path. So they go from here to here. So that's x. Okay. And then person Y, what do they do? Oh my goodness. They go 3/4 of the way around the path. Okay. And then the person Z walks all the way around. So they start here and they end here. So let's look at these displacements. So x has this displacement, y has this displacement, and z has a displacement of 0. So if I were to rank them, z is going to be less than y is going to be less than x, um, which is choice E. All right, a particle starts from rest in the origin. Its acceleration is this, and we want to know the x-coordinate of the particle and its y-coordinate is 12 starting from rest. So let's figure this out. So x equals 1/2 times 2 times t squared, and y equals 1/2 times 1 times t squared. So we have 12 equals 1/2 t squared. So 24 equals t squared. Let's not root that. Let's just plug it into here. So x is going to equal 1/2 times 2 times the 24, which is t squared. And I'm actually getting 24 meters as its x-coordinate. All right. We're moving in a straight line, and our speed is increasing at a constant rate. So that means acceleration is constant. And that means the net force is constant, but not 0. And then let's continue here. Problem 19. Whoa. So we've got this little problem here. We got a force accelerating a system with 2 blocks. Let's actually take a look at this. And there's no friction. So we got F. We've got the normal on X due to Y. We've got the weight of X. And we've got the normal on X due to the floor. And then for the 4 kilogram, we've got the normal on Y due to X. We've got the weight of Y. And we have the normal of Y. And let's just set up a couple things. So the acceleration is 4 meters per second squared. So we know that F minus normal on X due to Y is going to be 2 kilograms times 4. And then we also know the normal on Y due to X is what makes Y accelerate. And that's going to be 4 times 4. So I'm getting 16 newtons here for NYX. And that's the force on which Y is pushed by X. So by Newton's third law, NXY equals negative NYX. So we get a 16 Newton force. All right, we got a toy raft shown above. Oh my goodness, we don't show it, so I wouldn't do number 20. Just skip it. And I would have skipped that on anybody that did this exam. So that's the multiple choice. I'm going to put that online and put these solutions up for you right now in Haiku.